Well, the floor is yours.
So this talk kind of came out of a collaborative project that I had over the last couple of years with one other person. It was at a sort of improvised music thing, and at the time I was working a day job as a programmer, and then once a week we would play music for 4 or 5 hours, and I was using pure code, and they were using a differing array of modular and just sort of found things, and one of the surprising things about it was that it was how unsystematic it was, and I would sort of look back at the code that I'd written in process, sort of improvised in this improvisation process, and had no idea what it was, no idea sort of what I was doing, and it was hard to even pin down who was making what sound. And so part of this was me thinking through this huge gap between programming as this like very rational thing that I would sort of do all day, and programming is this like highly intuitive thing that was like almost opaque to me, even though at least in theory I knew what I was doing. I hope I knew what I was doing. So I'm going to start with this quote from Mellon Conway. This is generally referred to as Conway's law. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. Conway proposed this in 1967, and this was like experimentally confirmed actually in a sort of limited way, but maybe I want to think about it at a little bit in a little sort of broader and more open-ended way, which is like how do the structures, social structures, technical structures, and intellectual practices, how do they get baked into the code that we write and the things that we're sort of doing with code? And maybe more interesting for us, how can we avoid or sort of step outside of that mirroring? So I want to talk just a little bit about the sort of history of programming as a practice, and maybe get some insight there, and then think about some paths, some alternate paths. Generally, the sort of first programmable computer, there's a bunch of ways you can talk about this. It's usually referred to as the Eniac, which was a computer that was built just before the end of World War II. This is a picture of part of it. It was conceived in 43, it was designed in 44, and the production was finished in 45, which was also when the war ended. It was like just before the end of World War II that it was finished. It was built to produce artillery firing tables. Artillery was being produced at a rapid rate, and in order to fire it accurately, you had to plug in a bunch of values as far as weather conditions and elevation and blah, 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 in order to determine sort of what the angle was. This computer was built in order to more quickly produce these firing tables. At its peak, after the war, it grew to 30 tons. It was 20,000 vacuum tubes and 70,000 resistors. So this was a quite huge endeavor. The 6 lead programmers on this are sort of colloquially called the Eniac Girls, and that in and of itself is a really interesting history. And the reason why the programmers, or why early programmers were women, is also a particularly interesting history. There's a really, really nice chapter in a book by Wendy Chun called Program Divisions that talks about the way that sort of early programming is gendered. It's really, really worth reading. So this was programmed with punch card input, and also programmed by sort of physically actually repatching the machine to configure sort of different modules and the sort of signal flow through these things. There was no practice of programming at the time. So largely how this was programmed was kind of invented on the fly by the women who are kind of figuring out how to solve these problems. This is a diagram that was sort of used to track the state of the machine. One of the nice things about this is this diagram looks a lot like it could, I think I could very easily say that this was like a graphical score from like a 1950s experimental composer, and you all would be like, oh yeah, of course, it's a great piece. This is a nice photo of them patching this together. And also, I could very easily say that this was an early modular synth, and you would all say, yes, of course. So kind of working in this space, I found this interesting graph. So this is a graph of the kind of usable time on the machine. And the middle line, the solid line, is how much time it was actually operating and sort of producing results. The bottom one is programming, and I think that anyone who like uses code probably recognizes this this as well, that a large percentage of your time is spent debugging and not actually writing code or sort of producing output. Before this graph, off the left side of the graph, it's actually much worse than this, I think, in the earlier days. So this is a problem, right? Like, how do you design a process to write code to, like, you know, make this better? So there's a lot of development methodologies that evolved around this time and shortly afterwards. They all kind of turn into what's called waterfall development. This is now like kind of a derogatory term, but at the time it was like, you know, a sort of an innovation. And it's this like very sequential design process. It was proposed in 70, but it was just talked about as early as 56. And the thing to keep in mind is that most software development was happening either in military organizations, military contractors, or a few large companies. So this process sort of reflected those hierarchies and those power structures and those kind of organizational structures. Very militarized, very sort of top-down and structured. So this is a graph of kind of an early way of thinking about waterfall. And you can see why it's called waterfall, because it's this sort of like very delineated process, starting with requirements, and then, you know, coding and debugging in the middle, and then testing, and then, you know, maintenance at the end. Here's another one a little bit later that's basically the same thing in a V shape, but you get the idea. And, you know, as this evolved, you know, you get some more articulations of this that are still like quite linear and quite sort of stepwise. You'll notice that like all of them at the beginning, it's like, first there's requirements, then you move on from requirements, and there's no revisitation of that, right? This is like, you know, also incidentally, these also look like graphical scores from the time period, if you sort of squint your eyes at them. There we go. After this, as time goes on, we move into the sort of more modern era of organizing these processes, and you get to variations on Agile development, and there's a million different variations of this, test-driven development in Kanban and crystal clear and extreme programming and all this garbage. Agile is much more sort of touchy-feely and has this sort of vague new age kind of aura to it. It was laid out by 17 software developers at a ski resort in Utah, who now are all what's the word they use? Like trainers in this process, and have made $1 million.
Gurus, no?
They're kind of gurus, yeah.
Yeah.
And you can see these, you know, now there's cycles in this, right? But you know, so there's sort of these feedback loops where you're revisiting what you're doing, but it's still this very productized thing. And the thing to think about all of this is that really this is like an industrial process from the beginning of producing code, right? And it's tied to an industrial process. There's a product requirement that you have to build, and then you sort of step through it and then finish your thing. And even if there's feedback loops, within that, it's still this kind of process of organizing labor around production. So this is kind of an awful history to sit on if you're like a creative person trying to use code. You know, and there was a little bit in the 70s and 80s when programming was still this kind of like esoteric art. But you know, now we're in an era where it's like fully professionalized, and there's books of techniques and design patterns, and every university has programs. And even if you're not a professional programmer, maybe you are sort of doing things more creatively, you're still sort of living in this world whether you like it or not. If you use Git or GitHub, these are tools that were designed for these workflows. If you're debugging your code, this was designed, you know, for these workflows. I mean, if you write an API or a plugin, you know, all of these things were concepts that were built for this kind of production workflow. I mean, probably most of us know that, you know, the genesis of computer music was at Bell Labs, which is one of the largest monopoly corporations in U.S. history. So, these things are quite intertwined, but it's a little bit depressing to like think that these tools that we have are part of this lineage, and they may be leaking into our own practice even in ways that we don't understand. So I want to maybe rewind back to the beginning and think maybe a little more heretically about this history, and think about whether there's a different way to frame this that's more amenable to what we're trying to do, how all of us might want to use code, and that might escape some of these things. And I'm going to be I'll be a little like creative and a little fanciful with how I define this to see if we can sort of get enough escape velocity to like kind of escape from this problem. So let's start here, back at the beginning. So let's say programming is a practice of cybernetic mind enhancement, where the programmer uses a symbolic language to enter into a feedback loop with the computer in order to expand her capacity for imagination, for thought, for prediction, for hypothesis exploration, right? So in this story, the programmer uses code to create proliferating branches and more states. If you think about a computer as something that can embody many states at the same time, you create more states, you then observe the results of those states, you prune those graphs and you prune those branches and create more branches, and start to sort of sculpt this sort of space by observation and by direct engagement and interaction as you look at the results of the code that you're executing. So the nice thing about a computer is that it can embody many possible states simultaneously and jump between them. It can imagine more things all at the same time than you or I can imagine, and we can quickly explore those states. We can have a computer sit at this kind of virtual point between 100 different things and then quickly say this one or this one or this one. So this is not actually such a fanciful history or a sort of version of this. Douglas Engelbart, who was the inventor of the mouse and a huge person in the development of graphical user interfaces, said he had this paper, Augmented Human Intellect, and he said, by augmented human intellect, we mean increasing the capacity of a man to approach a complex problem situation, to gain comprehension to suit his particular needs, and to derive solutions to his problems. More rapid comprehension, better comprehension, the possibility of gaining a useful degree of comprehension, speedier solutions, better solutions, the possibility of finding solutions to problems that before seemed insoluble. So this was, I think, in the 60s, and even he was thinking about it as this thing that actually is about rapid exploration and really like extending what you can think of and how you can operate. So if we take this model, then for us, code becomes this kind of psychedelic tool. It's this tool, this sort of intermediary where we can dream with a computing device beyond what we could have thought of before. And this is our language to communicate with that and to receive communication back, especially when we enter into this kind of feedback loop where we're observing the results, writing more code, and sort of circling around. And this is not even so weird. Beyond Douglas Engelbart, this sort of esoteric idea of programming existed through the 80s and up until the beginning of the 90s. If you look at something like Mondo 2000, which was, if anyone's familiar with this, is a publication from, I think that ended in like 91 or 92 or something, that was through the 80s, was this kind of exact convergence of sort of 80s computing culture and like drug culture and West Coast sort of New Age, spiritualism, and all of these things kind of mashed together. And you can see like in this right-hand page, which is like really, really fantastic. Fractals are pitched as something to like reduce productivity, which is this like weird nexus of like software and sort of creative stuff, but also like talking about reducing productivity is very much like, it's situated in still programming as this like industrial kind of action. So Mondo 2000, just not that long after this issue, then turned into Wired magazine, where most of the counterculture stuff was scrubbed, and it became the kind of manual of like the current era of like techno-libertarianism and you know, the kind of whatever remaining countercultural cruft was there kind of like fell off. So the question then is, we have these two histories. We're kind of stuck in one, and we have another one that kind of peaks up now and then, but is not really the way that things have gone. So how can we dream of this heretical history while actually living with the reality of software tools and practices that we have now? So I want to stop at this quote from William James, a psychologist. He said, "But we must admit that the organizing systems of paths can be thrown out of gear with one another, so that the processes in one system give rise to one consciousness, and those of another system to another simultaneously existing consciousness. Thus only can we understand the facts of automatic writing. Each of the selves is due to a system of cerebral paths acting by itself. If the brain acted normally, then the dissociated systems would come together and get a new affectation of consciousness in the form of a third self, different from the other two, but knowing their objects together." So what he's talking about here is automatic writing. He did quite a lot of extensive study of automatic writing, as did a lot of psychiatrists. So there's kind of two things that automatic writing is that are sort of superimposed. One of them is an occult version of automatic writing. Writing executed without the agent's volition or knowledge, under the control of a spirit or non-human entity, right? So this was like, you would go into a trance, you would communicate with some sort of entity outside of yourself, and you would write without knowing what you were writing, and then you would come out of the trance and sort of discover what was being told to you. And there's all kinds of versions of this, drawing and speech even. Then there's a psychological version. So the occult version was quite popular in the 1840s, or, you know, at the peak of the spiritualism movement. Not that long after that, psychologists got interested in it, particularly Pierre Genet, who was studying dissociation, and wrote a lot of sort of early work on dissociative states. In fact, Terence Hines says, in fact, automatic writing is just an example of a milder form of dissociative state. That is a state where you act but don't identify your actions as your own. So there's kind of a third sort of thing to this, which is around this time, a lot of artists were interested in either or both the occult version of this and the psychological version of it. Of course, like Robert Ashley famously has his piece Automatic Writing, but William Butler Yeats was heavily invested in automatic writing. He did seances with his wife for his entire late career, and much of his writing is derived from that. Gertrude Stein did early experiments in automatic writing, and of course the Surrealists, automatic writing and these kinds of unconscious processes were like a core part of the Surrealist interest. So there is kind of a art juice to be squeezed from both of these things. So one of the most sort of interesting and talked about cases of automatic writing was Helene Smith. She was a spiritualist and a medium in the late 1890s. She held a lot of public seances and was quite popular. She channeled Victor Hugo for a long time, who would like write poems to people, and then a bunch of other famous individuals. But the thing that she was most known for was her Martian writing. And in this period, which I think was like 7 years or something, she would do these seances where she would go into a trance and sort of a deep sleep, and she would travel to Mars and live amongst Martians. And she couldn't understand what they were saying, though she would listen to their speech, and then it would be interpreted for her by this SNL character who is some sort of entity that has lived on both Earth and Mars and can sort of translate for her. And she would write down this Martian language, in these trance states. And this is an example. I think the left is a Martian alphabet, and the right, I believe, is something that she called Ultra-Martian, which was a different race of Martians, and these are like pictographs. It was like a pictographic language. So she did this for 7 years. There was a lot. There was several psychologists that followed her, and also she was just quite popular. Surrealists were obsessed with her. So writing about her writing, Martian, the language, had all the characteristics of a language. Moreover, over the course of 7 years of seances, it remained strikingly stable and structurally consistent. And somewhere else, I'm just quoting this, as a dictionary of Martian words began to come together, it became clear that Martian had a close correspondence with French. She was, need I say it, she was French. On the other hand, Flournoy, the person who was studying this, found it difficult to find any grounds on which to link its lexicon with that of the speaker's native tongue. The Martian vocabulary resisted his best attempts at decryption. So it was in this sort of weird state where it was kind of like derived from French and had echoes of French, but also was like quite creative. It was not just, transposing words or anything like that. Someone later did a more detailed work and actually was able to trace hypothetical etymologies of a lot of the words to several languages that she sort of plausibly could have known. But it is this, it's this like quite sophisticated and long-running set of writings. And you actually see there's the same thing with William Butler Yeats's wife, whose name I cannot remember. She wrote fantastic things coming from her automatic writing processes that are, if you analyze them over the years, they're like really this like rich and detailed kind of like world and set of conversations with different spirits that she was talking to. So bringing this back to the original conversation of writing code, I want to think about whether writing code for us can become a kind of seance. I think when you're writing code, when any of us are writing code to deal with the materiality of sound, to influence sound, we want to have this kind of intimate relationship to it. And this relationship may be blocked or hindered by all of the kind of practical and sort of professionalized processes in writing code. I think that many people are probably familiar with getting to the point in a creative project where all of a sudden you're actually just tool building and not doing sound anymore at all. This is a super slippery slope. And so I wonder if this is a way that we can think about programming that might, again, in the way that Helene Smith was able to write this entirely constructed and sort of fanciful language that was still kind of structured like a language, and still kind of, still French, without sort of knowing it. I wonder if that gives us a sort of path through this problem. So sort of like leave with a few questions. Can we, when we're writing code, and when we're using code to really deal with material, sound material, how can we forget our knowledge while still knowing how to program? Because of course, you sort of can't do anything. You want to build technique and you want to have skill with what you're doing, but you also want to forget it in a sense. So how can we enter a state where we may know things, but we're dissociated from them, and at least temporarily forget them? And if we're thinking about this as a seance, then who's inhabiting us, if not us? Or who would we like to be inhabiting us? Are we inhabited by the composers that produced this piece? This one? Are we inhabited by the alternate universe where this was electroacoustic music and that's what we're channeling? Who else should we be ascribing this to? And what can we imagine? And can we use the sound that we're creating to help untether us? Sound, I think, is quite transportative and can pull us away from the immediate world around us, and I think it when we're generating sound, we can use that as a tool to kind of decouple us from whatever our technical processes are. And finally, can we act as our own psychologist or anthropologist? In other words, can we write code or build systems in a tight feedback loop where we don't know what we're doing, and we've left behind technique and left behind our knowledge for the moment where we're operating it, communing with something else, and then can we go back and study it not to understand or to sort of build our system better, but study it from the perspective of an anthropologist, saying who produced this, what produced this, how did this get produced, and what to do with it, how to interpret this. I'll just leave you with this really awesome picture of this person automatic writing, and we can imagine who these two individuals are that are actually creating this act.
Questions? Comment? Reaction?
How do you think that this might be realized? Like, have you gotten a chance to try to do this by any chance?
Yeah, I mean, so going back to the beginning, like, this is sort of what ended up happening with this project. I would once a week for 2 years would play music with my collaborator, and I would write code we'd play for 4 or 5 hours at a time. And by the end, I would have no idea what I had done, where the sounds were coming from. The code was sort of a little bit incomprehensible. I mean, I could figure it out, of course. But all of the attempts that we made to kind of systematize it, we had a couple performances where we'd be like, let's rehearse this one part. Let's go back to this state. That was quite good. And it sort of never worked. And at some point, we had to sort of acknowledge that what was really happening was, happened only when we had kind of been in this space for an hour or two and had really gotten into this very intuitive relationship with the sounds we were making. And that's, so this talk was partly just me trying to think through that process and like how you get there and what value there is there.
I have a comment maybe, because you asked those interesting questions at the end. Yeah, so the first one intrigued me a lot, like how can you forget what you learn? I'm not a coder,
Mm-hmm.
I'm a musician in that sense, not classically trained. But what I usually do, I try to switch tools.
Mm-hmm.
And sometimes when I start a new tool, other than the computer, because the computer has infinite possibilities,
Mm-hmm.
I start to learn different things.
Mm-hmm.
I start to use more my ears instead of my eyes.
Mm-hmm.
That usually helps me to forget what I actually know.
Mm-hmm. This
might be different for other people, but for me it works.
I think part of this state for me was putting myself in a position where I was like barely had a hold of what I was doing, and I think that rushed me enough that it was like I was like kind of barely holding on.
Could that be thought of as some kind of forced sideways step?
Mm-hmm.
Yeah, that your thought process have got to a certain point, but you force yourself to take a sideways step.
Mm-hmm.
Would then taking the new tool be?
Yeah.
Would that be a kind of generalization of the idea?
Mm-hmm.
Maybe I also mean with a new tool, other tool than a computer.
Yeah.
With the computer, like I said, so many possibilities,
Mhm.
endless, and you can calculate everything with it as
Yeah.
well. So maybe sometimes not knowing what you're doing is more interesting,
Mm-hmm.
or generates different results than you would have done in a computer. That's my point.
Yeah. No, to say what I was going to say is this. I think these questions are brilliant, or they really point to an essence of something. And what it comes down to me, from the stuff that I was talking about
Mhm.
and reading, is like programming as artistic practice. And while you were talking about automatic writing, I mean, I didn't mention that Duchamp, Dubuffet, Artaud, Elise, and several others
Mhm.
specifically say Heidegger, the artist is a medium.
Mm-hmm.
And this relationship that you're talking about of having with is like the relationship that you have as an artist with the thing that's coming into being,
Mm-hmm.
that and that you're interacting and relating and interrelating with.
Mm-hmm.
So I think that this is making like
Mm-hmm.
really thinking of coding as an artistic practice and thinking of an artistic practice as that kind of an artistic
Mhm.
practice.
Yeah, and I think that those narratives about coding don't exist so much. And I think maybe it's worth creating them. I think you did.
Yeah, kind of just following on, I guess, from a couple of the other points, is that I get we're a room full of music adjacent people who are involved in programming coding to differing extents. So I think this kind of dissociative mindset is perhaps more in the vocabulary or more in the kind of methodologies or experiences of music people, you know, the getting into the zone or whatever. I'm interested, have you presented these sorts of ideas to non-music/arts adjacent programmers, and would their reactions differ or their thoughts on this idea of?
That's a really, really good question. I mean, I think there's a lot of worth for if you're like working, because if you're thinking about music, especially as something that's real time, I think there's a lot of worth to like being able to pull yourself away from these like hyper rationalized sort of processes. But I don't know what the worth would be to someone who has maybe more rational goals of like writing good code or something. So I mean, I haven't talked to anyone about that particular part of it. I would be super interested too.
Yeah, well, just I'm trying to formulate something here, but following on from Ben's point here, that coding as an artistic practice, I mean, it's so different from the thing you described earlier from the 50s or 40s and 50s of the idea of already establishing your product goal right at the beginning of the programming process. So basically, your evaluation of your program process is really how you achieve that particular goal. So the artistic thing would be really that you actually have no idea what goal you're going for. That being essential, in some way essential to the artistic process. That would actually blow open quite a lot of artistic myths, wouldn't it? I mean, if you think that way about the artist having an idea of the whole vision of the whole, or am I wrong there? I don't know.
No, I mean, I think there's also quite a danger if you're doing arts that are not computing related at all of having this kind of like waterfall pattern of like conception and design and execution and then observation and like whatever. It's easy to fall into that pattern even if you're not writing code, and it's something to keep in mind. And it's also worth keeping in mind that quote that I had at the beginning, the Conway's law, which has been like kind of rattling around in my head, that the idea of it is like if you have 3 teams and they're remote from each other, then what you'll end up with is 3 components that are loosely coupled. And if you have a team of 5 people that all sit together, you'll end up with a bunch of small components that are tightly linked. But just thinking about this idea that like the processes that you're using to do the thing end up getting baked into the structure of what you're doing is like feels like something that's worth like reminding myself of all the time.
I was thinking about, I don't really know anything about coding, but I was thinking about that when you said about that, how would non-musician feel about it? And I kind of feel that dissociative state has very much to do with, first of all, repetition that you have had before the performance, and also, of course, the real-time immediacy of the performance. And I don't know if there is any situations in coding besides live coding. Are there other live coding things than musical aspects? Because I would think that if there are coders who have never played anything or who don't have musical background, but who are, for example, are hardcore gamers, they would probably recognize that dissociative thing when they play their computer game, and I think that's kind of same thing.
Yeah.
I don't know if there are other applications besides this.
Yeah, I mean, it's tough to say with the code relationship in particular. Nothing has really jumped out to me, to be honest. But I also I'm so intertwined with the music part of it that it's hard for me to kind of see outside of that.
Maybe with visuals, but I don't know.
Yeah.
I don't know how can I formulate my question, but can we make a link somehow with something like bending, coding, hacking a syntax or something?
No, I mean, I think that I had a lot more of this talk just around what it is to program a system. And I think when you start to really think carefully about what it is to like use code to structure this like space of possibility, add states, new states to the machine that it can possibly be in, and then maybe wander through those and find places to trim or sort of add new possibilities. I think there is something, there is something quite visceral about that, where you're like sort of hacking off certain trees and growing other ones in other areas. I think it is this, you could think about it as this intuitive process of kind of like feeling out this landscape and thinking, oh, there's more over here, I know that there is. Let me add some more parameterization or some other more chaos to this part of the system and see what it is.
It's interesting, this kind of dissociation of meaning of the meaning is not as direct. I mean, if you're very consciously programming some predefined structure, then everything has a very specific meaning. But maybe if the meaning is less, it's delayed until the result of something. Then so maybe and indeed the hacking is also often using the ambiguity of the meaning to have a command have a result that's not intended. So that but it's indeed
It's maybe ambiguity. But
somehow we need programming language which are ambiguous. But it's not it sounds frightening.
Exactly though, right?
That's also, well, we should all program in JavaScript, I guess. I mean, nothing is more ambiguous than that. But I guess that explains why I like JavaScript. I mean, it's so insane. It somehow works.
This kind of things that it's kind of against the common things. And for example, you have let and var in a JavaScript that can be confuse the variables. Where you write it, where you read it, and you don't have it in C. You cannot.
Well, even the types are kind of confused. So indeed, an array can be well. That's very specific, but I think there's something like in having an ambiguous language that can be.
But I think those things do. I think those structural things do matter. Even though this was a talk a little bit like throw away the programming stuff. Like those things, the systems that you're using do quite matter. And I think a lot about like Wittgenstein talking about in the Tractatus of like. The text being a ladder, and when you climb the ladder, you can throw it away. And I think about that as, in this context, as like, you still need this backend, right? You still need to know French, even if you're going to sort of write Martian. But the important thing is to like not be writing French anymore, I think.
Is there also something to say, concerning what you've explained about what actually the computer represents to us? That is the first computer, the Eniac that you mentioned. Programming meant actually directly writing binary values into a memory, whereas coding today can feel or can have become very remote from the actual binary representation, which is still there. Again, I don't really also have a question, but I can imagine that having gone further and further away from that has a meaning. And I don't know that there's something to find in going even further away, or even maybe going back to bits that can.
I mean, I think it's super interesting. Like, there's like, somewhere in this slide deck, there's like this many slides that are also about the history of programming languages and how they fit into this and how they've been directed by concerns around organizing labor and organizing knowledge and like monetizing knowledge and all of these things.
Make that you can make an invoice at the end of
exactly,
management also.
And so if we read that history and think about how that impacts like JavaScript code, for example, I think there's ways that we might be able to reverse engineer that. And again, like use it, maybe use it as a ladder, but then be able to throw it away once we get to some place where we kind of don't need to rely on the formalities anymore.
Well, I think we've come to the end of the questions. We don't want to spoil